and do some of those. Because you can measure some rows, pulleys, and things like that. So, but one new thing you're going to be working with today, so I want to give you a quick lecture on that, and that's the force of friction. So for the force of friction, I'll generally use that term, or that symbology. Everybody's probably somewhat familiar with the term friction. It's the resistive force between two bodies sliding across one another. We've got this box sitting on the ground there. What's the frictional force as drawn there? Action on that box.
What is the frictional force? Gravity.
Gravity is never a force. Gravity is always an acceleration field. Gravity's, remember, think about the units. Meters per second squared. Gravity is always acceleration. It can cause a force, but gravity itself is acceleration.
Weight.
And gravity, which direction is gravitational field? It's always down towards the center of the Earth. Let's back up a second. Which direction does that's another question we need to answer. Which direction does the force of friction always act?
Opposite.
Opposite of what?
What you're trying to act on?
Yeah, that's one way to define it. What's another way to define it?
Opposite of force.
Well, in terms of, it always has to act parallel to what? Ask that question. It's a shear force, so it always acts parallel to the surface where the friction is taking place. Friction doesn't keep my foot from coming up. It keeps it from sliding sideways. So, for me walking around the surface here, the frictional force is always in the plane of the floor. It's always in this plane. It's never up and down. It's within the plane of the floor. It's some pointing some direction. Okay, so now back to this question here. This box is just sitting there on flat ground. What's the frictional force? It's what? But what is it?
I would say it's zero if it's just sitting still.
That's right. It's zero if it's just sitting still. There is no frictional force. If the ground is truly level. How about somebody comes up here and starts pushing on it, and they're pushing, 20 newtons, a 20 newton force, but they're not moving the box. What's the frictional force?
Over 20 newtons.
Over 20 newtons?
They're trying to push it and they're not moving it.
Yeah. What's the frictional force? Let's say it's over 20 newtons. I'm going to pick a number. I'm going to say it's 21 newtons. Okay. The person is pushing 20 newtons that way. The force of friction is 21 newtons.
Oh, okay. So it's 20 newtons.
So let's use our vector analysis. We got a 20 newton, and then we got another 21 newton going this one. So you got a net force of 1 newton. So it would accelerate, it would move. So the friction would move it opposite the way you're pushing. That doesn't make any sense, right? So what's the force of friction?
20.
It's 20. We know that it's got to be equal. Okay, let's do another one here. Just a couple of thought experiments. We're pushing at 20 newtons, and this time this is no longer asphalt, it's slick concrete, and we're able to move that box. And we're moving it at, we'll make this math simple here, 1 meter per second. Pretty good little step. What's the force of friction?
$20 newtons.
Yeah. Why is it 20 newtons?